Assalamualaikum and good morning. I'm going to present about our mini project for electronic system. So this is our group members: Muhammad Azri bin Johari, Amir Azim bin Amir Hussein, Muhammad Laizat bin Muhammad Tazli, Jason Wong bin Muhammad Fitri Wong, Muhammad Iqbal Aiman bin Muhammad Zulfikri, and Muhammad Shazni bin Suhaimi.
Introduction. Based on the assignment given by our lecturer, we form a group to work on an assignment about electronic system. The system includes two windbridge oscillator circuit, an active low pass filter, a full bridge rectifier circuit, a voltage regulator, and a load. Next is electronic system block diagram. We given by our lecturer, we have two oscillator, one active low pass filter, rectifier, voltage regulator, and the load. We must construct a circuit by using this system block diagram. Next, oscillator 1. Oscillator type is Windbridge oscillator. A Windbridge oscillator is a circuit that uses two RC network connected together to generate a sinusoidal oscillator. It based on a frequency selective from the Wheatstone bridge circuit. Next is design specification. So we must calculate the assumed value. For assumed value, C is equal to 1.9 nanofarad. So we assume C2, C1, and C is equal to 1.9 nanofarad. Second, find the value of R by using formula and given frequency. R equal to 1 over 2 pi Fc. So we get R is 1.144.69 kilo ohm. After that, we recalculate the frequency with calculated value of R and C to check whether it matches the specification. So Fr is equal to 1 over 2 pi Rc. So we get the frequency is 997.84 Hz equally to 1 kHz. After that, we using the formula to calculate Rs and Rf by given the formula of AV equal to 1 plus Rf divided by Rs. We assume the AV is 3 and we derive the formula to get to Rs equal to Rf. Let's say the Rs is 33 kilo ohm, then we get the Rf is 66 kilo ohm. After that, note that the gain of oscillator must be around 3 so that the oscillation to be sustained. If the gain is less than 3, the oscillation will fizzle out. If the oscillation more than 3, the oscillation will produce distortion. Next, this is a circuit simulation and output waveform. For the two diode D1 and D2 is to reduce the noise after the sinusoidal wave. Next, this is a simulation of oscillator 1. So we run the simulation and we get the output waveform as this is the same. It's the same as the question for frequency. Frequency that we measure, that we calculate is 997.84 Hz, and we get the summation is 991 Hz. That is the result of summation.
My name is Muhammad Laizat bin Muhammad Tazli. I'm going to present about oscillator 2. Oscillator type Windbridge oscillator. So here is the design specification and calculation. Oscillator 2 calculation, we assume C equal to 1.9 nanofarad. So the capacitor C2, C1 is equal to C, which is 1.9 nanofarad. The second one is we find the value of R by using formula and given frequency. So the formula is R equal to 1 over 2 pi Fc. So the value that we get for the R is equal to 4.19 kilo ohm. So we assume is 4 kilo ohm. So R1 is equal to R2 and equal to R. So the value is 4 kilo ohm. For the number 3, we recalculate the frequency with the calculate value of R and see to check whether it's match the specification. So we using the formula for FR equal to 1 over 2 pi RC. So the value that we get is 20.94 kilohertz, and we assume the formula the value to 20 kilohertz. For number 4, which is use gain formula to calculate RS and RFA. So the formula AV equal to 1 plus RF over RS. So the AV is 3 equal 1 plus RF over RS. So we move 1 to the left side. So we get 2 equal RF over RS. So 2 RS equal to RF. So we let RS equal to 48 kilo ohm. So RF equal to 2 times 48 kilo ohm. So we will get the answer is 40 sorry 96 to kilo 96 kilo ohm equally to 98 kilo ohm. So this is the circuit simulation and output waveform. So we using the diode for non-distortion. This is the simulation for oscillator 2. So I will run the simulation. So the output for frequency is 18.0 kilohertz, and for peak to peak 1.29 volt.
Hello, my name is Jason Wong bin Muhammad Fitri Wong, metric number B0821100297. I will present about active low-pass filter. A low-pass filter allows frequencies below a certain cutoff frequency to pass through and blocks higher frequencies. Cutoff frequency Fc equals to 8 kHz and second order Butterworth response. And this is the design specifications. This is a calculation, and Ra over Rb is 0.586, the second order Butterworth response. Assume Ra is 586 ohm, frequency Fc is 1 over 2 pi Rc, and so 0.586 is equal to 586 ohm over Rb, and then Rb is equal to 586 ohm over 0.586, Rb equal to 1 kilo ohm. So we get Ra is 586 ohm, Rb is 1 kilo ohm. And then assume R is 1 kilo ohm. So we put in the value 8 kilohertz equals to 1 over 2 pi Rc, and C is 1 over 2 pi and 1 kilo and 8 kilo. So we get 19.89 nanofarad equals to 19 nanofarad. And then R1 is equal to R2 equals to 1 kilohertz. C1 equals to C2 is equal to 19 nanofarad. So this is the circuit simulation in multi-sim. And this is the output for 8 kilohertz. So this is the circuit simulation in multi-sim. And we run it. And we set it. This is the output for 8 kilohertz.
Hi, my name is Muhammad Azri bin Juari, matrix number B082110047. So I will talk about the rectifier, an electrical device which converts an alternating current into a direct one by allowing a current to flow through it in one direction only. So this is the calculation design specifications. So take the BPP from the output of active LPF. So V to value peak to peak is equal to 1.39 volt and VP is 0.0695 volt and the value of VRMS is 0.707 VP. So the equal is 0.707 multiplied with 0.695 will be equal to 0.491 volt. So this is the circuit simulation and output waveform. The output waveform will be present at the oscilloscope. For this output is the frequency is 13.4 kilohertz and the value of peak to peak is 691 millivolt. So this is for the circuit simulation. I will run the circuit. So this is the output for the circuit. The frequency will be 13.4 kilohertz and the peak to peak value will be the 694 millivolt.
Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Ami Azim bin Ami Hussein, matric number B0821101169. So I'm going to be presenting on voltage regulator type, operational amplifier, shunt regulator circuit. A voltage regulator is designed to automatically maintain a constant voltage level by reducing the input voltage to the desired level. It ensures the voltage remains stable even when a load is applied. So this is the design specifications or calculation for operational amplifier. So assume that R2 and R3 is 10 kilo ohm and voltage is 2.458 volt. And then the calculation for the voltage output is R2 plus R3 over R3 times with voltage equals to 4.916 volt. The input of the operational amplifier shunt regulator circuit is continuous from the output of the rectifier. So this is the circuit arrangement that we did on the multisim software. So the result that we can see from the multimeter 1 is 4.917 volt, and then the second multimeter we gain 2.458 volt. So this is the simulation for the multisim, and the first multimeter is for the voltage shunt 2.458 volt, and then the second multimeter is for the voltage output which is 4.917 volt.
Hello, my name is Muhammad Iqbal Aiman bin Muhammad Zulfikri. My matric number is B0821100006. So in my part is load. Load is an electrical component or portion of a circuit that consumes active electric power, such as electrical appliances and lights inside the home. The term may also refer to the power consumed by a circuit. So this is the design specification for calculation. Given P load required is 1 watt. Voltage load V equal to 4.917 volt. Power load equal to voltage load 2 times V2 over resistor load up. For the resistor load up equal to voltage load 2 times V2 over P load watt equal to 4.917 times 2 volt over 1 watt. So the answer is 24.18 ohm. This is the circuit simulation and recorded values. The V1 is 4.917, the R1 is 24.18 ohm, and the load is 9.67 watt.
Hi, I'm Yasindran. I'm here to present about discussion. We may examine how an oscillator converts a DC signal to an AC signal by summing the voltage amplifier's output signal, a circuit that can create a continuous repetitive alternating waveform without any input is known as an oscillator. Then by increasing the bandwidth of the filter, we employ an active low-pass filter to adjust the frequency responses and provide a more selective output response. The transition from a low-pass to high-pass filter is called an active low-pass filter. A rectified is a device that transforms a two-directional alternating current AC into a single directional direct current DC that oscillates. A voltage rectifier is also used to convert an AC signal to DC signal, which the operating system requires. Finally, the rectifier's output signal was sent to a rudimentary shunt voltage regulator, which controls the output voltage by shunting the current away load. For conclusion, we may infer that the project was assigned based on block diagram and that we need to finish 6 circuits, which will be integrated into the project's final step by using 2 oscillators to create a continuous waveform devoid of any input. In this project, the output response is made more selective by using an active low-pass filter to modify the frequency response from low-pass to high-pass filter. Additionally, a rectifier is utilized to convert an oscillating two-directional signal when the low-pass filter settles. Voltage regulators are used in this project to supply the power for output voltage, and we can accrue every reading for frequency for each circuit, and the entire circuit is the same with the calculation that we do using an oscilloscope. AC current is converted into a single directional DC current. Finally, using multi-sim software for this project enables PD team collaboration to solve any issues that may develop as well as to identify any mistakes.